Yeah.
No,
No, I don't know what the thing that I just called.
Okay, let's go ahead and knock out 6.8. This is just graphing,
Jesus.
which is really hard for me because I want you to be able to do this by hand. So let's get serious. You can get a graphing calculator on the test. Now on your state test, you will not, so that's why I want to make sure I teach you how to do it by hand in case it does pop up on the non-calculator portion of the exam. So we're going to be graphing radical functions. We're going to look at the square root and the cube root. Okay, so 6.8. Remember your old friend? It's back. Every time you think of graphing, Jonah, every time you think of graphing, you should think of this, okay?
I'm the only one who picked that.
No, but
Same stuff. The only one that's new is the yellow one. Because if we are looking at a parabola and we reflect that over the y-axis, what do we get? The same thing. So that's why we never had the reflection over the y-axis. But now we're looking at square root graphs and cubed root graphs. But if we reflect it over the y-axis, it is going to be something different. Okay? So everything else is the same in front. If it's a negative, it reflects the x. Vertical stretch, vertical compression. Left and right, up and down. That's all the same. Notice how I have an n as the index, because that applies for square roots, cube roots, fourth roots, you name it. All of those still apply. Remember, don't forget, your test is on Wednesday. We're reviewing tomorrow. Knock it out. Test on Wednesday. Okay, so with transformations, we first have to know the parent function. Okay, just like with quadratics, we had the parent function, which was that 0, 0, 1, 1, negative 1, 1, 2, 4, and so on. Okay, same thing, we're going to have a parent function for the square root and then the cubed root as well. So with the square root of 0 is 0. Square root of 1. So then the next square root would be 4. So square root of 4 gets me 2. What's so special about square roots? Where can I not go?
the lower.
No. Where can I not go?
Negative.
Negatives.
Got you.
So I cannot take the square root of a negative number. It becomes imaginary. All right. So with the square root graph, the parent function looks like this. Okay, you already told me square root of 0 was 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. I could keep going. That's our parent function. Our x values start at 0 and they go to the positive. Our y values start at 0 and go to the positive. That's the parent function. Of course, if it shifts, the domain and range shifts. Okay? You want to have this in your notes. The cubed root of x, cubed root of 0 is 0, cubed root of 1 is 1. The next one would be the cubed root of 8 is 2. Then remember, I can take the cubed root of a negative number. So the cubed root of negative 1 is negative 1. Cubed root of negative 8 is negative 2. Okay, so that's why that one looks like a little snake. The good news, and why you should really, really like the cubed root of x, every single time, no matter what you do to that function, it is always going to be all real numbers for both domain and range. Beautiful, okay? Literally, every single time you can reflect it, you can stretch it, you can move it up, you can move it down. Doesn't matter, that graph's going to keep going, okay? So every single time, that does not change that your domain and range is all real numbers every single time. It's important to have the actual points because that's what we're going to use to do the transformations to them. Okay, so let's look at, and I'm going to have to do this a little bit differently than what my notes look like because they have more multiple choice on there. Go ahead and graph that without a calculator. Especially if you get to use a calculator. Right now you're not, but especially if you get to. I want actual points. I don't want y'all to just sketch it. What transformation is happening here?
Left 2.
Left 2. Okay. So if I graph my parent function, 0, 0, 1, 1, 4, 2, 9, 3, and if I just do the dots like that, then it's simple. Move everything to the left 2. Okay, so my whole graph just shifted to the left 2. That's why it's important just to know those basic points. Then from there, you can do any transformation they throw your way. Okay? How would we handle a vertical stretch and compression? What would that change? Your X or your Y? Your Y, if you're vertically stretching or vertically compressing something, that's dealing with your Y values, okay? So what I probably would do on this page right here is I would put multiply A by your Y values, okay? Multiply A by all of your Y values. Okay? Let's make things a little bit more interesting. For fun, let's throw in that. Go ahead and first list off all the transformations that are happening. And I'm going to show you an easy way to make sure you can get all of those transformations in without making any mistakes. Okay, so just the transformations. This 2 tells me my graph does what? Okay, a vertical stretch. What about the negative inside the radical? Reflects the Y. Okay, what about this 1? Left 1. And this 2. Down 2. So that's a lot going on there. And I could do that on the graph each step, but that gets to be a lot of dots moving around, especially if you don't have an actual piece of graph paper. Okay? So how can we make our life easier? A table. Okay? So let's start off with our parent function that we're used to seeing. 0, 0, 1, 1, 4, 2, and 9, 3. Okay? So you'll always start with your stretching and compressing and reflecting and stuff like that. Okay? So we know that this negative here reflects our y-axis, okay? We know that 2 is our vertical stretch, okay? So if we're dealing with the vertical stretch, we said that changes our y, okay? And I said you're going to multiply your y values by that number, okay? So I'm going to do just that. 0 times 2 means 0. 1 times 2, 2 times 2, and 3 times 2. So I've done the vertical stretch. Okay. What about reflecting the y-axis? Who does that change? Your x. Okay. So if it was positive, now it's negative. Okay. Well, 0 doesn't change, but these change to negatives. Okay, so I did my reflect the y-axis. If I go left 1, Who does that affect? X or Y? X. So I'm going to go backwards 1. So if I'm at 0, I'm now at negative 1. And lastly, if I'm going to go down 2, that affects my Y. So I'm going to subtract 2. Now, I did a lot all in one just so you can see all these different changes. Now you have your new ordered pairs. -1, -2, -2, 0, -5, 2, and -10, 4. Go ahead and graph that. And if it was drawn correctly, it probably would look more like a square root. So if you looked at your parent function, notice how we reflected over the Y. We stretched it vertically, so that's why it's wider. We moved it to the left 1 and down 2. Okay? So that one has a whole lot of transformations in it. I think you have maybe 2 or 3 at the most on your homework. Yeah.
So since you have a negative in the square root, how does that not give you like imaginary numbers?
Because that's why the graph has shifted. Look at your new input values. They're all negatives. So if I inputted a -1, it'd be -1, which is 1 plus, and then go on from there. Yeah, good question, man. What's my domain here?
There's something over here.
-1.
Something over there?
Yeah, sorry, I'm trying to
Negative
answer the
one.
question.
-infinity to -1, or X is less than or equal to -1. Okay? So that has changed. Okay? Questions on transformations with square roots? Y'all, it's the same thing with cubed roots. You take those 3 dots in the middle and the 2 on the ends, and if you have to reflect them, you have to stretch them, if you have to do whatever, same transformations apply, okay? Let's see what else I got on here before I get too far out of this. Let's try this one. But I want to do the cubed root. Just so we can see one as an example. Go ahead and do your dots for your parent function. Acknowledge the transformations. And then use that to then move the dots. the table work for you, stick with the table. If you notice that you're only going left or right and up and down, you can probably just move one of them at a time. Or two at a time, depending on what level you're at. So if you are someone that really likes the table, if I go left 2, I affect my X value. If I go down 1, that affects my Y value. Whoops, that's not right. -2, -1. 0. So if you notice, whoops, I don't know why it did that. You notice my graph has shifted to the left 2 and down 1. I could have taken every dot and literally go 1, 2, and then down 1, plot it. Left 2, down 1, left 2, down 1, left 2, down 1. Okay, some of us need that table because it kind of displays everything that's going on. Okay. So for tonight, you're doing both 6-7 and 6-8 homework. Tomorrow we're going to review and test on Wednesday. Okay. Let's see here.